Hey there, everyone. I wanted to make this video to do a few examples of linear regression so that those of you who haven't turned in the baseball stats regression project or have turned in something that is incomplete um, can do so and finish the project. So in the project, if you look at the directions, you're asked to find three examples of regression results. Strong correlation, medium correlation, and then weak or no correlation. So I'm also going to send out with this link to this email an attachment, which is the document somebody turned in for this assignment, which resulted in a very good grade, so that you can see exactly what I was looking for. This person followed the directions pretty closely and got, I think, maybe even a perfect score. Okay, so what you want to do is look in that data set, that spreadsheet, and find two variables either on the individual tab or on the team tab that demonstrate and then, I'm sorry, you find two variables that you think are related in very strongly related or very weakly related. Then you import those columns into Desmos and perform the regression, and you check the correlation coefficient to see what range it falls in. If it's less than 0.3, it's weak or moderate or no correlation. Between 0.3 and 0.7, it's moderate correlation. Greater than 0.7 is really going to give you is really strong correlation. Okay, so let's dive in and do an example of this so you can see how to actually perform the regression. Okay, so I actually in the project, and I don't even mind if you use these categories since this obviously isn't an exercise in, I don't want this to be an exercise in what your baseball knowledge is. But so I actually came up with some examples that you could use. So let's see, for strong correlation, I came up with total number of runs scored versus total number of wins. So this is from the team offensive stats page. So probably the number of runs a baseball team scores is likely to propel them to have a better winning season than a team that doesn't scores fewer runs. So to test that, what you need to do is what I did is I copied the column total number of wins, okay, onto the temporary worksheet page. And then I copied total number of runs scored onto that same page. So total number of runs scored is column L. So if I copy that, and I really make total number of runs scored be the X variable, so it would really go first, because if you think about it, really the number of wins is a result of the number of runs scored. The number of wins a team has doesn't cause the number them to have a higher number of runs scored. It's the result of them having a higher number of runs scored. So that's why the number of runs scored, also called the independent variable or X. So you want to put that column first, and then once you get them side by side on the temporary worksheet tab, you highlight both the columns by clicking up here on the letters and dragging across, and then do Control C, and then you go into Desmos just in a new graph and do Control V. Okay, so maybe I didn't copy and paste them in correctly because this is not what it should look like. Oh yeah, I think I'm off. Ooh, I was doing the wrong let's see. Total number of wins, total number of runs scored. Yeah, I was on the wrong page. I was on the individual page for one of them. So total number of runs scored is actually K. Total number of wins for a team is column E. So let me fix that. Okay, so no wonder I was not getting the right values. Okay, so you should have the same number of rows if you did the copying correctly, which I didn't the first time, and that was kind of my first clue that something was up. So let me go back into Desmos now. All right, and then let me get rid of this because that's the wrong data. And then I'm going to do Control V. No. Now I have run scored versus run scored. Not what I want. I want number of wins. Trying to talk, concentrate at the same time. Not as easy as you would think it is, would be. Okay, so let's do number of wins. There we go. Okay, let's hope third time is the charm here. So now back to Desmos. All right. So I do Control V. Okay, there we go. All right, so you can kind of see a pattern, right? As the number of runs scored increases, the number of wins a team is likely has, it also kind of increases in a pattern, right? So now I'm ready to do the regression. So if you look, my variables were automatically named x1 and y1 by Desmos when I pasted the values in. So that means I have to use those variable names, and because I'm doing linear regression, I'm going to type y1 and then the squiggle symbol, which is to the left of the 1, and you have to hit shift to get it, and then mx1 plus b. Okay, so I get a correlation coefficient of 0.81. All right, so that's strong correlation. All right, so it means that, you know, the number of wins is pretty closely related to the number of hits or the number of runs scored that a team has, right? Which is why it's important to have baseball players who can score runs, right? Because if you don't score runs, you're not going to win too many games. The more runs you score, the more likely you are to win games. Okay, so that one pretty much makes sense. So then I also did like one that's moderate correlation, and that one turned out to be number of hits as the x variable and number of runs scored as the y variable. So you would kind of think the more hits players have on a team, the more likely the team is to score runs. Because getting hits is really the main way in baseball that you score runs. Let's see, I think I reversed this. Hold on, I think I dragged the mouse. So now there are other ways to score runs, right? You could get people on base by being walked, in which case they could be in scoring position and they could score. A team could score runs that way by getting on on base, being walked, and then maybe having a few players, you know, just fewer players get hits to drive those players into home who were walked. But let's see what happens. The proof will be in performing the regression. Okay, so I'm going to highlight both columns. All right, and then I'm going to copy and paste into Desmos again. And you can actually leave it on the same graph if you want. Okay, so now it looks like there is a relationship, right? It kind of looks like a pattern that goes up. So the more hits you have, the more likely you are to score runs. But let's see what the correlation coefficient is. So we have y2 and x2 are our variables this time. So I'm going to do y2 and then the squiggle symbol, and then mx2, and then plus b. Okay. Uh, well, you know what? That actually is strong correlation too. It's point correlation coefficient of 0.74. I thought it might be mild correlation, but it's actually strong, or moderate correlation, I should say. So let's try, how about number of hits and number of wins? Okay, so that's the beauty of, it's pretty easy to just try different variables to see if there's a relationship. So I would think there would be a relationship between the number of wins and the number of hits. Maybe not quite as strong as the number of wins versus the number of runs scored. I mean, if you think about it, a team could get all kinds of, maybe their players only hit singles and doubles, whereas if you have players who really hit home runs and triples, they're more likely to bring in more runs. So even though the team with many hits, they still may not do as well as a team with fewer hits, as long as the hits that they do have are more likely to be home runs and triples, especially home runs. So let's see. So I'm going to paste that into Desmos. And we'll see what we come up with here. So let me try this again. Maybe I did not copy. Okay, there we go. X3 and Y3 and X3. Okay, so not quite as clear of a pattern. It kind of looks a little bit like a blob, but it does look like kind of loosely that as one goes up, the other goes up as well. So I'm going to do Y3, squiggle symbol, MX3 plus B. Okay, and yeah, I get a correlation coefficient of 0.49, which is moderate, weak to moderate correlation. Okay, so that means there are other factors, right? Many more other factors that may contribute to a team winning more games without necessarily having the most hits. There is some relationship. It's a strong contributor to the number of wins. But, for example, maybe a team is an awesome defensive team, all right? So they prevent the opposing team from scoring very many points, and as a result, they don't need as many hits to win the game because they just need more than the other or more runs than the other team. So if they prevent other teams from getting many hits or scoring runs, for that matter, then they don't have to score that many or get that many hits themselves. So that would be maybe a possible explanation why they're not, like, there's moderate correlation but not strong correlation. And then in my third example, I did an example of weak correlation. So let's see. So weak correlation, you might think, and at least I did, with players, that maybe taller players might be more likely to hit home runs. Well, let's see. So in our data set, we have the top 100 players by batting average. All right, so we're going to do, and this was on the individual player offensive stats. So I copied and pasted number of home runs and the column that has the player's height in inches. Okay, so I know I read a story that, baseball players have been getting taller and taller over the years. Now, like, if you're not 6 feet tall, you're considered short in professional baseball. So, the reason would be, you would think that maybe there must be some advantage, maybe not quite as much as in the NBA, where height can be a big advantage, but maybe there might be some advantage there. So let's look at the top 100 players, and we're going to run linear regression to see if there is a relationship, if taller players are much more likely to have more home runs. So I'm going to, once again, here, let me just get out all the other ones so that I've cleared up the things a little bit. Okay, so that looks to me like no correlation. If you see just kind of a blob of data of scattered points and there seems to be no rhyme nor reason, then it's probably that there is weak or no correlation. Now it looks like there might be a little bit of correlation. You can kind of see that if you draw a line right through the kind of going up from left to right, you might kind of look like there could fit a line there, but let's see. So this is, let's see, what am I up to? Y1 and X1 again. So I'm going to do Y1 squiggle MX1 plus B. And we get correlation of 0.28, which is considered weak, very weak correlation. Now, it's not no correlation, really. No correlation is close to 0. So there is a little correlation saying that taller players, at least among the top 100 players for batting average, tend to hit a few more home runs than shorter players. But it's not very strong. Now, it would be interesting to see, this is only the top 100 players. It would be interesting to see the top maybe 300 players for batting average, or all of players except for, I would exclude pitchers, because pitchers are kind of have a very unique role, but and they're not hired based for their hitting ability. But all other players, it would be interesting to see if the relationship was stronger across all players, or if it's the same as with the best players, which these would be the 100 best offensive players, really, for the most part. Okay, so those are 3 examples of strong, moderate, and weak correlation. And what you need to do is, once you've come up with an R value in the specific range, and I don't even mind if you use these examples, then you want to either do a screen capture of the whole screen, including what the R value is and the regression line with the scatter plot of all the points, or you can export the image and then put what the correlation coefficient was, and then what the equation of the line is. So the equation of the line, basically it's y equals mx plus b. Well, the regression model tells you what m and what b are. So like in this case, the equation of the line would be y equals 1.31909x minus 70.5057. Okay, and that's useful because knowing the equation of the regression line would let you be able to make predictions about how a specific value of x is going to, what value for y you would expect, all right, which gives you the ability to kind of predict things, which is, how money is made in the world. If you can come up with scientific models for predicting outcomes, and this is what the Oakland A's did if you watch the Moneyball movie. They started developing mathematical models and player metrics that maybe traditional teams were kind of overlooking, their scouts were overlooking, and they were kind of powering their team and what players they drafted to be on their team based on some rather unusual statistics, which turned out to be, and they turned out for the most part to be correct. They kind of turned the team around, at least early on, until all the other teams started catching on to what they were doing and started hiring mathematicians, mathematical modeling people. So, but yeah, this project was supposed to give you a taste of that. Yeah, so once you come up with your graphs, paste them into the document. Make sure you have what the correlation coefficient was, write out the equation of the line, and then just a sentence or two about why you think either the variables are closely related, somewhat related, or not related at all. So, all right, so hopefully that helps, and the few of you who have not finished this project can finish this project, as it's going to be a major part of your marking period grade for marking period 2. All right.